Okay, so let's start, guys. So good afternoon, everybody. So last time I explained interrupts. I explained number one, the concept itself. I told you it's very important. That's for sure. Okay. And so the main, I'm gonna quickly just make quick revision on what I said. So the idea of interrupts is that, for example, here there is an event, okay, or let me say it in a different way, there is an interrupt request coming from the hardware. So the hardware is requesting interrupt, and because of that, the microprocessor is gonna leave the main program, execute a subroutine, and come back. Okay, so the microprocessor is gonna suspend, very important, suspend the main program, go execute subroutine, and come back. Okay, and that's what you should see in the coming lab, also in test 2. Although the microprocessor is gonna suspend the main program, but because the microprocessor is super fast, you are not gonna feel it is suspended. You are gonna feel everything is running simultaneously. Okay, and this is the beauty of interrupts, multitasks. Okay, I can run several tasks at the same time because we don't have only one interrupt subroutine. We have several sources of interrupts. That means it can, so here you have several sources. If interrupt come from here, go execute this one, come back. If interrupt come here, go execute this one and come back. If we can do this, if you can do this fast enough, you will feel we are running several things at the same time. That is why, because of interrupts, I can run multiple tasks. Your program is not gonna be written in one place anymore. What we have done so far from the beginning of the semester until now, we ran only one task, and we wrote our program in one place. So what we have done so far from the beginning of the semester, just one task, and it was inside main. Okay, now, no, your program can have several tasks, as you see in the coming lab. Okay, and here I'm gonna write the code for one task. Here I can write the code for another task, another task, another task, another task, and so on. Okay, and the beauty, so or the reason for that is microprocessor. Let's agree on that. In our basic microprocessor, it can only run one instruction at a time. One instruction at a time. Is that okay? But again, because it go execute, come fast, you feel like everything is running at the same time. So the idea is that microprocessor does not need to do everything by its own. Microprocessor can delegate some work to the hardware to take care of it. For example, as I told you last time, I want to count for 1 second. What we did in chapter 3, delay, the function delay, microprocessor has to count for 1 second. Is that okay? We can do something else. We can ask an external timer. That's what I'm gonna teach. We can ask an external timer to do counting, to count for 1 second. And when it is done, when the counting is done, it's gonna interrupt me. You get what I'm saying? So microprocessor doesn't need to do everything by its own. Hardware is gonna check. Also, for example, if there is, and that's what we're gonna do in the coming lab. Every time I press the push button, I'm gonna generate a signal, something like that, and this should trigger interrupt. Okay. Again, microprocessor does not need to come and to check. Is there a signal? No. Is there a signal? No. Is there a signal? No. Doesn't need to do that. There is a hardware circuit that's gonna take care of that. The hardware circuit is gonna monitor. It's gonna monitor this pin. Once it finds a falling edge, for example, or rising edge, this is something you can program, as I'm gonna explain. Once it finds a falling edge, so it's gonna interrupt the microprocessor. So some work, same thing, guys. If you have a serial communication circuit, okay? So in case of a serial communication circuit, microprocessor doesn't need to come here. Have you received a byte? No. Have you received a byte? No. Have you received a byte? No. Microprocessor doesn't need to do that. So I'm gonna leave the circuit the circuit is gonna receive, once the circuit receives a byte, it's gonna do all the communication, okay? And then it's gonna trigger the microprocessor. This is the main idea. This is how can we make big programs. We have some hardware that's gonna do some work, and when it is done, it's gonna just notify or request the interrupt from the microprocessor, okay? So also, okay, so this is the main idea. Now, how can we implement this idea? How can we do it, okay? And once you understand how can you do it, you are gonna understand how can we program it, okay? And the good thing, as you will see today, is that the way we program it almost the same. So it's just a copy and paste, similar when you program a pin, like input or output, okay? So it's almost every time you just copy the same code, you just do small changes. It's exactly the same thing here, as you will see. Anyway, so in order to implement this idea, as I told you last time, we need to answer, or we need to do several things. The first question we need to ask, or the first thing we need to know is, okay, you told number one, as we agree, we have several sources of interrupts. So we have several sources. Okay, every source has its own subroutine. That's okay. So we have several subroutines. We call it interrupt subroutine or interrupt routine. Okay, number one, what is the location of this subroutine? So when I receive interrupt from the timer, where in memory I have to go to execute the subroutine? Where? Okay, this is the first question. And the answer is, as you see here, we have something we call it vector table. So as you see here, guys, we have fixed addresses. So these addresses are fixed. So what we do, we have one word. We have one word here for each interrupt source. Is that okay? For example, let's talk about this one, the timer. For example, for the timer, yeah. For the timer, you can put the subroutine anywhere in the memory. It's okay. Put it anywhere. It's up to you. However, in order to make the processor, in order to enable the processor to know the location of the subroutine, you have to put the beginning address here. This location is fixed. This location is, so every time microprocessor is gonna receive interrupt from the timer, is gonna come here, take this address, put this address in BC, so that it can jump to go to this location, execute the subroutine from there. Okay, same thing for every interrupt here. Okay, these locations are fixed. You can put the subroutine anywhere. It's totally fine. However, the beginning address, you have to store it here. Okay, guys? And what I told you, you don't need to do that, because the project you created is going to do this for you. All what you have to do is that for every interrupt subroutine, you have to use some names, fixed names. You cannot change these names. You cannot. Why? Because the project using these names, the project already is going to put the addresses here. You can understand? But if you are creating your, if you don't use the project we create, if you are creating your program from scratch, number one, you can use any name. Number two, you have to store the addresses here. Okay. Anyway, so this is the first question we need to ask. So in programming, okay. So now I want to translate to programming. In programming, we have several, by the way, the word handler is similar to interrupt, okay? So we have several interrupts, as you see here. In this chapter, I'm going to teach this one. Also, I'm going to teach the system tech, which this one should give a timer, okay? In the future, I'm going to teach other things, but anyway. So in programming, all what you have to do, if I want to use this interrupt, so you have to create a function. You don't need to define this function. Just to create this function with this name, and then right here, whatever you want to do when this interrupt is triggered. Is that okay, guys? Great. This is number one. Okay, what other issues we need to do here? Okay, as I told you also last time, okay, the second issue is priority. Priority. So what priority means, guys? As I told you last time, if you have several interrupts, binding interrupts. So I have interrupt coming from source 1, source 7, source 9, source 11. So I have several binding interrupts. Okay, which one I have to do first? Which one I have to serve first? Serve. The word serve means execute its own subroutine. Is that okay? Can I have a control on that? Does it matter? Sometimes it doesn't matter. If your program does not have like something like time sensitive, or it doesn't have something like very critical, you want to do it first, okay, so it doesn't matter. Okay. However, sometimes it matters. Sometimes I need to give this is more important, or this time sensitive than this one. So if this interrupt comes with other interrupts, you have to do this one first. Yes, you can control it. How can you control it? Using priority value. You can assign a value for each source. You can assign a priority value for each source. Yes, what's your question? Oh, you don't? Okay. Also, we need to answer another question related to this one. Okay, guys. If this is interrupt source one, interrupt subroutine of source one, okay, and then I'm executing this interrupt, and came another interrupt request that came from S2. So while the processor is executing the interrupt subroutine of S1, okay, another interrupt came. Now we can do one of two things. Number one, okay, choose just don't service this interrupt until I finish. So after I finish, so I'm gonna go do this one. Yes, you can do that. The other thing you can do, no, this you have to preempt. So the word is a English word, preempt. So preempt means no. What you have to do is that if this interrupt is very time sensitive or more important, this one, you have to go execute this one first and come to here. That's what we call preemption. Okay. So also this another thing. Can I control it? For sure, you can control it. Okay. How? As I told you, every interrupt first you put some value, some number. The number you put is gonna decide if this interrupt should preempt. So you should understand what I mean by preempt. Preempt. So preempt means if I'm executing one interrupt, okay, and another interrupt comes, should I leave this interrupt to go execute it or wait until I finish? Got what I'm saying? So preempt. So also, if I have several pending interrupts, which one I have to do first? So I told you last time, there is an interrupt value number. And as I make it clear last time, the lower the number, the higher the priority. It's the opposite. So if you have value 1 and you have value 5, so 1 should have more priority than 5. Is that okay? So as you see here, guys, we have what we call interrupt priority register. So in this register, you can put for every source. So every source, this is actually array of bytes. Every source has 1 byte here. Every source has 1 byte. And in this byte, you can put the priority value. And the way they do it is a priority, although it is a byte, but actually we didn't use the first 4 bits. We only use these 4 bits. So the way we do it, guys, as you see here, we have 2 bits from preemption priority. We have 2 bits for sub priority number. What is the difference between them? This one should determine, okay, preemption priority should determine if this interrupt should preempt this interrupt or not. So if I'm executing, let me make it very easy. If I'm executing an interrupt subroutine, okay, with the value 3, for example, okay, this is the preemption. And another one came with 3 and 3. So should I leave this interrupt and go execute the other one? The answer is no, right? So in order to leave this one and execute the other one, the preemption priority here has to be higher. That means the value is lower. For example, here, the 1, for example. So if 1 comes, so I'm going to leave this one and go execute 1 because, so this one, these 2 bits can determine if you want to, when preemption can be done. Okay. Again, this is one thing. The other thing here, guys, is that if you have binding, as I said, if you have several interrupts binding, like source 1, source 2, source 3, okay? And I need to decide which one I have to take. Number 1, I'm gonna look at the preemption priority. If 2 of them have the same value, at this time, I'm gonna look at which sub-priority number. Okay, which one has higher sub-priority number. Is that okay? Anyway, and based on that, I can select 1 because I cannot execute more than 1 interrupt subroutine at a certain time. So it has to be 1 by 1. Okay. Anyway, so I told you the way you can do it, guys, is you can use this function this way. The first one here should be every interrupt has a number. Is that okay? As you see here. So as you see here, every interrupt here has a number. So here you have to put the interrupt number. Here you have to put the interrupt number. Here you have to put the value. Or you can do this way if you want. So in this case, again, what you have to put here is the interrupt number, and what the interrupt numbers again here for every source are here for every source. Okay. These are different sources of interrupts. Okay. And then here you have to put the value, what value you want to put. Anyway, I don't think for the purpose of this course, I'm going to focus much on priority. So why you spend much time and explain it to us? Because maybe in the future, in your capstone, whatever, you can have some time sensitive operation, like you are doing some kind of communication. If this one comes, it shouldn't wait. Okay, for example, so you should know there is some kind, you can control it. Okay, but I think for most of what we are going to do, we may not need it. Okay, so we don't, it's not going to make big difference if you in some application. It's not important. Some application, other applications are important. Okay, guys. One more thing here I want to explain as well. Here I'm talking again. Here I'm talking in general for any interrupt source. Is that okay? But when I come to every source, I'm gonna repeat what I said here, but I will be more specific. Okay. So let's talk now about enable or disable interrupts. Okay. So once I enable interrupt, or once I start configure an interrupt source, do I have a control in this source? What do you mean by control? I mean, can I disable and enable it? What if I don't want any interrupts from this source for some reason? Okay, as you are going to do in the coming lab, by the way. Okay, so what if you don't want to trigger any interrupts from one source? Can I do that? The answer is yes. Why? Because you have the capability to enable or disable interrupts. What do you mean by enable or disable? Enable means, again, what's interrupts? It means every time there is event or request for interrupt, you are going to execute a subroutine. Serve the interrupts. That's the meaning of it. So what's the meaning of it is disable. Disable means even if you request the interrupt, I'm not going to serve you. I'm not going to execute the subroutine. That's the meaning of it. You understand what I'm saying? So if an interrupt, if you disable an interrupt, that means even if the interrupt request is interrupt, you're not gonna serve it because it is disabled. You're not gonna execute the subroutine. Okay. So how can we do that? As I told you last time, guys, for the peripheral we have, okay, we have two bits. So we have one bit here and we have another bit here in what we call NVIC. NVIC, this is a hardware, and this one is nested vector interrupt controller. So this controller should coordinate interrupts. So this is responsible to take care of interrupts. There is one bit here and one bit here, okay? And one bit, that's it. All what you have to do, if you want to enable interrupts, you have to put one here and you have to put one here. That's it. You got what I'm saying? You have to enable the both bits. If one of them is disabled, okay, so it is disabled. So you have to make sure both of them are enabled. Is that okay? Okay. So where is this bit? This is different from one source to another. When I teach specific for any source, I'm going to tell you where is this bit. Okay. So, however, for system exception, let me go back to tell you what I mean here. What I mean, we have interrupts for peripheral, and that's what we're going to use most of the time. We have some interrupts coming, we call them system interrupts, okay? Like, for example, if there is like a hardware fault somewhere or whatever, we're not going to program them, but we are going to only focus on this one, because this one is like a timer, as I'm going to explain. We can use this one because this one is a timer. We have another timer here. I'm going to teach it later. But so this is called system because this is for the system. It's not for a peripheral. So we have another timer here, by the way, but this one is peripheral. So anyway, so if you have a system, so in case if you have a system exception, in this case you have only one bit here, but you don't have one bit here. Is that okay? So that's what I'm saying. In case of peripheral, so you're gonna have two bits, one here and one here. Is that okay? And you have to enable both. However, in case of system exception, which actually is only, I'm gonna only teach system tech. In this case, we have only 1 bit instead of 2 bits. Okay. So now the question is that, okay, you told us you have to enable this one, and you told us I asked you where is the location of this bit. You told me I'm gonna teach later because this one is gonna the location of this bit, enable bit. So every time I teach a bit peripheral, I have to tell you where is the enable bit. Is that okay? Because this one different from one source to another. But for this one here, we have one register, 1 bit for it, for 1 bit for each peripheral to in. So actually here, look here, I know it's a little bit confusing, but try to understand what I'm saying. Sometimes they do this way, you guys. At least look here. For this one, we have only 1 bit. If you want to enable, you have to put 1. If you want to disable, you put 0. Only 1 bit. 1 enable, 0 disable. Is that okay? Here, they do it in a different way. The way they do it, here we have two registers. Every source has 1 bit here and 1 bit here. Is that okay? 2 different bits. 1 for enable, 1 for disable. Again, sometimes they do this way. You will see in this course. Also, sometimes that they do this way as they did here. Okay. So 1 bit for enable, 1 bit for disable. So here, what happens? As you see here, inside this one, we have 2 registers. This one for enable and this one for disable. And every so that means, so this is if I want to enable, I have to go to the bit of this one. I have to write 1 here. If I want to disable, if you go put 0 here, it has no impact. If you want to disable, you have to come here and put 1 here. So every time I put 1 here and disable, everyone. Again, let's make it easy. So the way, because I told you we have one bit here and we have bit here. Okay. If you want to disable a peripheral, you can just use this one. You don't need. You can leave this one, just one. But you have. But in the beginning of the program, you have to make sure this one is enabled, and you can keep it enabled all the time. And then if you wanna enable or disable interrupts, you can just use this one. Okay. Again, if you want to use this one, it should be okay. You understand what I'm saying? So you can keep this one enabled all the time if you want, and then if you every time you, and that's what we're gonna do in the lab. Anyway, so we have 2 registers as you see here. Every source has 1 bit in each of these registers, 1 for enable, 1 for disable. Okay. So now the question is, which bit? Which bit in this register for which source? Very easy. The bit number is actually the interrupt number. What this means, I'm going to tell you. I'm going to go again. As I told you, every source has an interrupt number. So this one has number 0. This one has number 4. Okay. So the bit, the location of the bit for enable or disable is going to be the same like this one. The same. Okay. So here this one should be bit 20. This one should be bit number 23, and so on. It's very easy. All what you have to do, we have 2 registers. For example, if I wanna select this one, so I'm gonna go to bit number 22. If you wanna enable, you have to put 1 here. If you wanna disable, you come here with put 1. That's it. Okay. This is for NVIC. Okay. And that's what I'm explaining here. Here you have to put the interrupt number. You have to put it here. And you can, as I'm showing here, this is the register for enable. Okay, I think. Yeah. So this is the register for enable. You have to write 1 in the location. Here you have to put the interrupt number. Here you have to put the interrupt number. Is that okay? So that you can shift this one to the location of the bit, enable or disable bit. Again, I'm writing 0 has no impact. So this is how it is. As I told you, sometimes we use only 1 bit for enable and disable. 1 enable, 0 disable. Sometimes we do this way. Here they do it in a different way. Here you have 2 different bits. Okay, and you can only write 1. If I write 1 here, enable. If you write 1 here, disable. Write 1 here, enable, disable, and so on. Okay. Anyway, or so you can do this way, guys. So and you can do this one for disable. Okay. Or you can just use this function. If you go inside this function, you can find these 2 are written already in this function. So I have 2 functions here, 1 for enable, 1 for disable, and then you have to put here again the interrupt number. Okay, guys, any questions? Okay, so what I explain now, guys, is again, I explain we have 1 bit here, 1 bit here, and 1 bit here. This is for 1 source, for 1 device. peripheral. Okay, only one. So this is to enable or disable one source. Sometimes I need some kind of global or group disable. Okay, sometimes I need to disable all interrupts. I want to do something important. I don't want to any interrupts from any source. Okay. Yes, can you do that? Yes, you can. You don't need. I don't need to write like 20 instructions to disable 20 sources. You understand that? Like, yeah, I don't need to go write 21 to disable source 1, source 2. No, you don't. There is one instruction to disable all of them. Okay. And that's what I'm teaching. That's what I said last time here. Yeah. So for example, here in this register, if you call this function is going to put 0 in this register to disable all interrupts. If you put 1, you are going to actually enable interrupts. But be careful here about the wording. Okay, you are going to. It's like this is like a master key, but still, and you have enable bit, local enable bit. So even if you enable the master key, the interrupts are not going to be enabled unless you enable the local bit. You understand what I'm saying? So master key is not enough. It's like a master key. Anyway, so still, yes, you have to enable this one, but that's not enough. Still, the local bit should also be enabled. Okay. Also, so here this one can enable or disable all sources of interrupts. We have also, sometimes you can enable or disable a group of interrupts. So for example, I wanna disable any interrupt, okay, with a certain priority value. I can do this way. For example, as you see here, guys, if I call this function using this register, you can just write to this register. For example, if I call this function, I put 60. What this means? That means you want to disable any interrupt source with priority value same or higher than 60. So any source that has same or higher than 60. So here you disable all, but here you disable just a group. Okay. And now if you put 0, you actually enable them again. Any questions? The last thing I want to explain here, guys. Okay. If you want to trigger interrupt, what should you do? Okay. What the device has to do? Okay. To complete the story. Okay. If you want to interrupt me, what would you do? As I said last time, you have to raise your hand. Okay. You raise your hand. Once you raise your hand, so you are telling the hardware, I want to trigger interrupt. Is that okay? So that's exactly what happens. So there is a bit, sometimes we call it interrupt flag bit, or sometimes you call it interrupt binding bit. So what happens if there is a hardware want to trigger interrupt, the hardware has to put 1 here in this bit. This is exactly when you raise your hand. So once you put 1 here in the hardware, this one is going to propagate in the hardware to request interrupt from the microprocessor. Is that okay, guys? So every source has 1 bit. Okay, every source has 1 bit. The hardware is responsible for writing 1 here. Okay. And as long as there is 1 here, that means there is a binding interrupt. There is an interrupt that's not served yet. It's not served yet. And then what you have to do is that in the interrupt subroutine, you have to write an instruction here to clear this bit because you already served it. You got what I'm saying? So now, hardware is going to put 1. You, in the software, your responsibility as a programmer, in the interrupt subroutine, you have to write an instruction to clear it because I already served it. You understand what I'm saying? I already served this interrupt, so I have to clear it. So that's exactly what happens. So, and then once you clear it, if there is another interrupt in the future, hardware is going to put 1. You are going to go execute the subroutine, and then the subroutine is going to clear it, and so on. You understand the story? What happens if you forget? Very serious. Right? And I have a video. I'm going to show the video. What happens if you forget to clear it? Yes, that's true. So you are gonna how should your program work? So your program should work this way, guys. What happens? You have a main. You have interrupt source here, interrupt source here, interrupt source here. Most of the time I'm here in the main, but when I get something, I'm gonna come back, go and come back, go and come back, go and come back. Is that okay? That's how it should work. However, if you forget to clear this pending bit, what's gonna happen is that you are gonna go execute this one, come back, and then the hardware will think this is a new request. So it's gonna go again, come back, go and come back, go and come back. So what's gonna happen all the time? You are gonna be here. You are not gonna execute this one. You are not gonna execute. You are not gonna execute this one. You are not gonna execute the main. You got what I'm saying? I want you to do it, man. Guys, I want you to learn. Just play. So in the coming lab, I forgot to write it, but anyway, I forgot to write it in the lab. In the coming lab, just don't write it. Or don't. I'm gonna tell you in the coming and see what's gonna happen. So, what's gonna happen? You will see. Your program is not the task you are putting here. This task is not gonna work. The task you are putting in the timer, it's not gonna work. But because all the time you are here, okay? Because you have continuous interrupts. Because you forget to clear the flag bit. You understand what I'm saying? Any questions? Okay. Now I just here using some kind of animation. I want to show you the whole story. Nothing is new, but the whole story. So as you see here, guys, we have this interrupt source. For example, interrupt source number 9. It is enabled, as you see here. It is enabled, but it is enabled here, and this is the bending. Bending is 0. That means all of them are zeros. So that means there is no interrupt. Is that okay? Because of that, I'm here in the main program. I'm doing the main program. Once the interrupt comes, as you see here, as I told you, what's going to happen when interrupt comes? The hardware automatically, now, as you see here, there should be 1 here. This is when you raise your hand. Okay, 1 here. Also, the hardware automatically is going to push registers. How many registers? So it's gonna push how many? Several registers, like a status register, R15, R19. So it's gonna push all these registers automatically to the stack. This is done automatically, okay? And then push to the stack. And then after that, after you push automatically push the stack, you are gonna leave the main program. You are gonna go to the vector table to find the location of this interrupt, okay? And then I'm gonna take this address, put it in PC. Yeah, so that, as you see here, we are gonna go execute the interrupt subroutine here, okay? After you finish the interrupt subroutine, we have to pop this once again, okay? You can see here, because we already executed, yeah, this one was 1 here, guys, as you see. Once you execute the interrupt subroutine, we are gonna clear it. This one is cleared. Oops. Yeah, and now the active is 1. So we have 1 active, and we have no bending. No bending. Is that okay? So after you execute the interrupt subroutine, what's gonna happen is that you are gonna pop all, as you see here. You are gonna pop all of them, and then you are gonna return to the main program again. Okay, any questions? Nothing is new. That's exactly what I explained. But again, because there are several things, I just put them together. We have a stack. We have here the vector table. We have several registers here. 1 for bending, 1 for priority, 1 for active, 1 for enable, if it's enabled or not. Okay, so all of you should work together to execute that. I want to give you here another example for preemption. I told you what is the idea of preemption. If I execute 1 interrupt and more important interrupt comes. So I'm gonna skip this one, I go to this one. You know what I'm saying? This is in here in this example. So here in this example, guys, as you see, I have these 2 interrupts. Okay, I have several interrupts here, but again, none of them is requested yet. 0 pending is 0 and 0. Okay, so we assume this one came first, but look at the number here. Priority. This one is 5, this one is 3. So this actually has more priority than this one. Makes sense? Because the lower the number, the higher the priority. Anyway, so see, so this one came first. External 3 came first, as you see here, okay? And then we are gonna push, as I just explained, and are gonna go execute the subroutine. While we are executing the subroutine, this one came here. Okay, this one is more important. So what's gonna happen? I'm gonna leave this one in active, and then I'm gonna go to this one. So if you look at the active, we have 2 active here now. Okay, so I'm gonna do stacking again. I'm gonna go to execute this one. After I am done with this one, I'm gonna return to this interrupt. When I am done with this interrupt, I'm gonna go to the main program again. You got it? Yeah. So now I'm gonna complete this one, and then after I complete this one, I'm gonna go to the main program. This is what we call preemption. Again, this one you have to do it if you have like something time sensitive or something very important. If any interrupt comes with this one, so you have this one should be executed first. Okay, guys, any questions? Okay, this slide is very important because that's what I'm gonna use it. So here I summarize for any interrupt source. To program any interrupt source, what should I do? You have to do these steps. Okay, so to program any interrupt source, what you have to do, guys. Number one, in the main program, okay, if you are interested in priority, you can set priority. I'm not going to do it, at least in the coming programs, because we don't need it. But for sure, if you are interested to set priority, you can set priority. Okay, this is number one. Number two, I need to write some instruction for configuration. And this configuration is different from one source to another. For example, if you talk about timer, in case of a timer, you need to set the timeout. I need periodic interrupts every 1 second. So you need to do configuration. You have to write instruction to do that. That okay? However, when I explain the external interrupt, as I'm gonna do right now, when you push a button here, you are gonna generate a pulse. This pulse is gonna go to the pin, a pin here. Okay, every time here you need. That's what we call external interrupts. So the idea of external interrupts means there is a pin here. Every time a pulse comes, I need to execute, I need to trigger interrupts. And this pulse can come from a sensor, it can come from a human. That's what we're gonna do in the coming lab. We're gonna do it from a human. So every time I press the button, I'm gonna generate a pulse like this one. When this pulse comes to the pin, a certain pin, so actually you are gonna trigger interrupt. Okay, so now you have the choice. Do you wanna trigger interrupt at the rising edges? Or you wanna trigger interrupt at the falling edges? Or you wanna trigger interrupt at both rising and falling? This is configuration. Okay, guys? So what I'm saying, in the main program, number one, you can write some instruction to set priority. Number two, you need to write some instruction to do configuration. And this configuration is different from one source to another. So specific for every source. Again, here, this one is general. Now I'm going to give you details. Okay. And then also, you have to enable interrupts. That's what you have to write in the main program. What you have to do in the interrupt subroutine, okay? Number one, you have to create a function with a certain name. The names I told you about, okay? And then inside this function, you should not define this function. You should not define, because this function is defined by your project. You know, when you create any function in C language, you have to declare the function first, and then you have to define it, okay? In this case, you don't need to declare it because this is something already done by your project. Okay, so just to put the function, okay, with a certain name. Also, don't forget to clear the interrupt pending bit. Okay, now I'm gonna go to the details. This is in general. So when I come to every interrupt source, I'm gonna tell you how can you do this one, and so on. Any questions? Okay, so let's touch this one, guys. External interrupts. What this means? As I told you guys, what this means, there is an external pin. I want to trigger interrupt when there is falling edge, or when there is rising edge, or when both. So one interrupt here and one interrupt here. Yes, you can do that. Okay. So this pulse can come from somewhere. Okay, it can come from a device, can come from a sensor. As we are going to do in the coming lab, it's going to come from user. So every time I press this button, you are gonna trigger interrupt. You get what I'm saying? Anyway, so I'm gonna here. That's what we call. Not all interrupts. Some students are confused here. Not all interrupts have external pin. Not all of them. For example, this one is a timer. The timer is actually something internal. So this is the microprocessor, and there is a timer circuit here. So it doesn't have an external pin. Not all interrupters have external pin. You get what I'm saying? Some of them are internal. Okay. Anyway. So now, so actually for this one, for external one here, you remember when I explained general purpose input output, port A, when I explained port A and port B, you remember what I did? Okay. Every port of them can have numbers from, for example, port A0 until port A15. Okay, so 16. Or port B from 0 to 16 P. Maybe not all of them are used in our processor because this is a very small processor. You got what I'm saying? But it can have numbers. So we have one pin for BE0 until BE15, and it's the same thing here. Okay. So let me say here what I want to say. You can take any one of these pins, okay, and use it for external interrupt. So any pins I used in chapter 3 as input output, right? These pins, you can program them to use them for external interrupt. Is that okay? However, there is an important point here, guys. Look here. However, I cannot use these two simultaneously. I have to use only one of them, and this is called line 0. And same thing for PA1 and PB1. I cannot use both of them. Only one of them can be used, and this is called line 1. By this way, we can have up to from line 0 until line 16. Sorry, 15. Every line you can use either BA0, for example, or BB0, only one of them. And in bigger processor, in our processor, we only have A and B. But in bigger processors, maybe you have A and B and C and D and so on. So we can only use one of them, BE0, BB0, BC0, BE0. So all of them, you can only use one of them, and this is something you can control. So again, you can have up to 16 external pins, okay? And you can, as I have just explained right now, you can link them to the external pins as I'm gonna elaborate for you now, okay? So you can have up to 16 external interrupters from this one, okay? Here, that's what I'm saying here. So for example, you can use BE0 or PB0, okay, one of them, but you cannot use both. And this is what we call line 0, or we call it external 0. So external 0, that means, okay, you are using either BE0 or BB0 or BC0 and so on. For sure, if you have, right? If you have more, but we have only these two. So one of them. Okay. Any questions? Okay. I'm going to elaborate now. So as I told you guys, here we have an external pin here. We have some hardware here. This hardware should detect if there is a rising edge or falling edge or both. And then after that is going to trigger interrupt. So the processor does not need to do polling. As I explained to before, the processor does not need to check this pin because there is a hardware circuit that's going to do that. Okay. So every time there is a pulse, the hardware here will detect it and just to notify me. So, okay. So I have some assistant. So I have some people to assist me. I'm the processor. Okay. So I'm going to give you a test. I don't need to do it by myself. You know what I'm saying? So every time you see a pulse, let me know. Okay, so I'm going to do the work instead of doing. I can do it by myself. However, if I do it by myself, I cannot do other things. You got what I'm saying? This is the main idea. Anyway, so now, as you see here, guys, so I can use this one is actually this is line 9. This one is line 10. Okay, and so on. So for example, this is 0, and this is 0. So as I said, you cannot use both of them because you can only select one of them. Anyway, so what I'm gonna do, guys, I'm gonna explain how can you program BA5. Okay. I'm gonna explain how can you program this one. Why? Simply because, as I explained before, this one is connected to a switch, so that it's easy to generate every time it's connected to a push button, so that every time I press the push button, you are going to generate a pulse here, just to make it easy to trigger interrupts. That's what I'm saying. So why I selected this one? I selected this one because it is easy to trigger interrupts. Why? Because as I explained before, there is an external circuit. Every time I press the button, I'm going to generate a pulse on this pin. So, and then once you do that, you trigger interrupt. You got what I'm saying? Anyway, yeah, so that's what I said before, guys. So that means if I can use, again, you can use any, I think I'm very clear. You can use any pin. You can use any pin. However, if you want to use any pin, you need to make sure you have to connect external circuit, or it has to, this one has to connect it to a sensor. It has to connect it to somewhere that's going to generate a pulse this way to trigger interrupt. Is that okay? I'm going to focus on this one, or also you can use this one if you want, because you don't need to connect external circuit. You don't need to connect external circuit. It's already, they are already here. You got what I'm saying? So that's why I focus on them. Okay, now, as I told you guys, for any interrupt source, for any source, I have to tell you where is the enable bit. Okay, I told you, let me go back. I told you for every source there are 2 bits, right? One of them I already told you about, the NVIC, right? So here I told you there is 1 bit here, and I already explained to you how can you enable or disable this one, because you already have 2 registers. I have just explained that, and you have to use the interrupt source. Okay, sorry, the interrupt number. Okay, now I'm going to talk about this one here, because this one is different from one source to another. So here for the external interrupt, yeah. So here for this one, guys, in this register, we have a register external interrupt, and then under this structure, this register is called interrupt mask register. So we have interrupt mask register this way. Okay, very simple. It cannot be simpler than this one. Just one register. Every line has 1 bit. That's it. Very simple. Okay. So if you want to enable one line, you have interrupt this. You have to put 1. If you want to disable, just put 0. It cannot be easier than that. You got what I'm saying? For example, as you see here, guys, if I want to enable line 2, okay, so I'm going to put here number 2. If I want to enable number 7, I'm going to put here number 7. Okay. By the way, I'm going to show you today how can you program PA5. PA5. Okay. I'm going to make a quiz on Thursday. Okay. In the quiz, I'm going to ask you to program PAX. X can be something else. I'm not going to tell you what is this. I already told you what will be in the quiz, but I cannot tell you specifically. Okay. So I'm going to show you how can you do one, and then I'm going to ask you to do another one. Very easy. Okay. So all what you have to do is that here in case PA5, so I'm going to put here 5. If I tell you in the quiz, I want to program BB. By the way, it doesn't matter if it is BA5 or BB5. Here it doesn't matter, because both of them are line 5. Okay, both of them are line 5. So it doesn't matter here. Here it doesn't matter. Anyway, so if I tell you in the quiz, I want to program BA9 or BB9, for example, all what you have to do in both cases, you just put 9 here for enable. Okay. For sure, if you want to disable, you just put here 0. Any question, guys? Very easy, very trivial. So you have here 1 register. This register has 1 bit for every interrupt source. You want to enable, put 1. You want to disable, put 0. That's it. Yeah. Number 2, the second bit. I told you I'm going to repeat. That's why I already explained, but I'm going to repeat for NVIC for the second bit. Okay. Look here, guys, and this is a little bit tricky. Listen to me. So I told you we have interrupts can come from XTI, external, from 0 until 15. Okay. Does it mean we have 16 interrupt subroutine here? The answer is no. Okay, how? I'm going to tell you how. Look here. What the way they did it, look here, guys. If you have an external interrupt 0 or 1, so this one for 0 or 1. So if interrupt comes from 0 or interrupt comes from 1, this subroutine is going to be executed. You get what I'm saying? So they share. So interrupt 0 or interrupt 1 or interrupt external 0, external 1, they are going to share the same subroutine. But someone can tell me, no, but wait a second. I want to do something when the interrupt coming from 1. I want to do something else when the interrupt coming from 0. So when they share, I'm going to execute the subroutine. No, the answer is no. The answer was going to be yes, you are going to call the subroutine. However, inside the subroutine, you can check. So what I'm saying, this subroutine is going to be executed when interrupt comes from 0 or 1. But inside the subroutine, you can check. If interrupt coming from 0, I'm going to do that. If interrupt coming from 1, I'm going to do that. You understand what I'm saying? So still you can be specific inside the subroutine itself. What I'm saying here, guys. So same thing here, 2 and 3. This one be executed. This one, 4 to 15. So 4, 5, 6, 7, 8, 9 until 15. So any interrupt coming from external 4 to 15 is going to execute this subroutine. Again, it's not a problem because here I can check. If interrupt coming from 4, do this. If this one is executed because it's coming from 5, do that, and so on. You understand what I'm saying? So just as they share. And because I want to program BA5, so 5 is here. If I ask you in the quiz, you have to program BA3, so you have to use this one. If I ask you, you have to program BA1, so you have to use this one. Or BB1, also it has to be this. It doesn't matter if it's A or B, because this one for line, not port, it's for line. Okay? Any questions? Anyway, so this is the name I have to use. And you have to understand this subroutine is going to be called if you have interrupt from 4 to 15. And inside it, you can check. I'm going to tell you how can you check. Okay? So now, okay, I told you the second enable bit should be here inside this one. If you want to enable, as I told you, all what you have to do, guys, this one here, you have this instruction for this one for enable, as I told you, right? We have another one for disable, but you can just simply just keep this one enabled all the time and just use this bit for disable with this one for disable or enable, because you have to enable the 2 bits, as I told you. Anyway, so all what you have to do, guys, here, the location of the bit should be the same, similar to the number here. Okay, so that means if you want to enable interrupts for this one, I have to put 1 in location number 7. So in number 7, I have to put 1. Okay, to do that, I can do something like that. So I have to put 1 in location number 7. Okay, that means in the quiz, if you have to do this one, so all what you have to do, just to put 5 here. If you want to do this one, you have to do here 6. Okay, anyway, but for this one, I'm gonna put 7. Or you can use this function just to give me the number 7 here. Or some people hate numbers. I want to use English words. So what happens, guys, in your project, in this project, they define some constant values. So you can, instead of using number 7, you can use this value, this English name here. You understand what I'm saying? It's the same because it's already defined here. So again, what I'm saying, you can use number 7, or you can use this English because it's already defined in your project. This one is defined with 7. Any questions? Again, if you go to this file, you find all of them are defined here. This one. Anyway, number 2. So again, so now, if in order to configure the external interrupts, number 1, you have to enable this bit. Very easy, very easy. Number 2, you have to do this one in the main program, as I have just explained. In the main program, you have to do this one. Okay, you have. If you want, again, if I go back, that's what I told you. Number 1, I'm not gonna focus much on priority, although you can do it if you want. I already explained how you can do the local because the global is already, it is enabled. You just focus on you can only focus on the global. Now I'm gonna talk about configuration. What kind of configuration you can do now? If I want to use external interrupt, what kind of configuration I want to do. Okay, you have to do two types of configuration. Number one, you have to configure the pin itself. This has nothing to do with interrupts. Okay, so as I told you before, the pin can be input or output. Because I'm going to use this pin for interrupts, it has to be input. It has to be input because you are going to input, not output. Okay, so any pin you are going to use, you have to configure this pin. And the configuration here will be identical to what I explained before. Nothing is new, except something very minor. It's not a big deal. It's very minor, okay? So here, nothing here is new. It's similar to what I explained before. If you want to use any pin, because the pins I'm going to use for interrupts are going to be similar to the port pins I used before. You know what I'm saying? Something very minor here. I'm gonna program it to have like pull down resistor here, pull down resistor. Okay, just why you wanna here put pull down resistor? I'm gonna as I explained before, but we didn't put it. But here I'm gonna tell you why. The reason is that if you look here, guys, based on the circuit we have here, if you don't press the button, so actually if you don't put this resistance here, this pin is gonna be float for sure. That's not good thing. By the way, in our board, we don't need this resistor. Why? Because if you remember, there is an external resistor. Because of this external resistor, if you don't push the button, I'm going to have 0 here. So the 0 is going to come from here. Anyway, so again, it depends on what kind of configuration what kind of circuit you have here. So in our circuit, again, what's important is that if you don't press the button, there should be 0 voltage. It cannot be float, right? To do that, you either, and that's what we did in our board, we connected external resistor this way. Okay, if just for peace of mind, what I did, I just used the configuration to connect. It's not going to hurt if you have one external and one internal anyway. Or if you are sure you have one external, you don't need the internal. You understand what I'm saying? What's important is that if I don't press the button, there should be 0. It cannot be float. So if you have external resistor, you are okay. If you don't have, so you have to connect one internal. Okay. Anyway, that's a very minor thing. So here actually, so the first part here, this configuration is similar exactly to what I explained before. Any questions? Okay. What other configuration you have to do? Very simple thing. As I told you guys, when do you want to trigger interrupts? When do you want to trigger interrupts? At every time the pin has rising, or it's up to you, or you want to trigger it when it has falling, or in both, when it has rising and falling. So one interrupt here and one interrupt here. It's up to you. It depends on what you want to do. Sometimes it doesn't matter. You know what I'm saying? So this is configuration you have to do. How I can do it? I'm going to tell you how. Look here, very simple. For rising, we have 1 bit. If you put 1, I'm going to capture rising. If you put 0, you are not going to capture rising. For falling, we have another bit. If you put 1, different bit. So here, so we have 2 different bits. You understand what I'm saying? So 1 bit to capture rising or not, the other bit to capture falling or not. So if you want to capture both, you have to put 1 here and you have to put 1 here. Very simple. Is that okay? So where is the location of these 2 bits? I'm going to tell you, very simple. So we have 2 registers. This one RTSR. RT is actually rising trigger selection register, something like that. So here in this register, guys, as you see here, we have 1 bit for line 0, line 1, line 2, all the way until line 15. Okay. We have another one F for falling edge. We have 1 bit for line 0, line 1, line 2, and so on. Okay, so very simple. So this one for rising, this one for rising, another register for falling. Very easy. So here, if I wanna select only rising, I am gonna put here 1. Here is 0. That's it. If you wanna only trigger interrupts at falling, so I'm gonna put here 1, 0 here. If you want to trigger both, so I'm going to put 0 and 0, as you see here, guys. So if you see here, yeah, here. And here, this is line number. So in the quiz, if I tell you line number 9, very simple. All what you have to do, just replace this one, put 9. And instead of bit number 5, it's going to be bit number 9. That's it. So as you see here, guys, if I put 1 in the bit number 5, here I'm focusing on bit number 5 because I'm going to use BA5. I'm going to use BA5 to trigger interrupts. Is that okay? So here you put 1, that means I want to trigger interrupts at rising. If you put 0, that means don't trigger interrupts at rising. Is that okay? Here, so 1 bit for rising, 1 bit for falling. Any questions? Yes, sure.
Said it would be on both the top and falling edges that we set the bits to 0 for both of those. Why wouldn't it be 1?
Why can it be one bit or?
No, just when you said when it triggers on a rising and falling edge,
yes,
we both put a 0. I just thought it'd be the opposite way. That is the way it's configured.
No. So here 1 bit for rising, 1 bit for falling. Is that okay? If I want to capture rising in this bit, I'm gonna put 1. Did I say the opposite?
No, you said when we did both, we put a 0.
No, 1 and 1. Here, maybe I made a mistake. So here 1 again. So either rising or falling, there is 1 bit here and 1 bit here. Okay. If I put 1, so that means you want to capture rising. If I put here 1, you are going to capture falling. What I'm saying. So if you want to capture both, maybe I made a mistake. If you want to capture both, you have to put 1 and 1.
Yeah, thank you.
Yeah, maybe I made a mistake. Okay, guys. I think it's very clear here. Yeah, anyway. Okay, what else other configuration I have to do? Is that everything? So let me summarize what I said. So in the main program, I need to do configuration in the main program. The first configuration I have to do, I have to program the pin input, and that's what we have done before. Number two, I have to select, do you want to capture rising, falling, or both? That's number 2. Number 3, and this is the last thing, number 3, I told you, we have line 0. Line 0, it can come from BE0 or PB0. So how I can select it? You get what I'm saying? Because I told you, here, for some processors, you may have port A, port B, port C, port D, port E, we don't have all of that. But just in case you have all of these ones, so actually all of them are going to share the same line. All of them are going to share the same line. You understand what I'm saying? So BA7, for example, if X is 7, so BA7, BB7, BC7, I cannot use all of them simultaneously. You have to pick up one. You got what I'm saying? This is line 7. So you have something like, for again, make it easy. For our case, we have only 2. And we have a multiplexer here. So there is a multiplexer. This multiplexer should select. Okay. For example, for line 5, I'm interested in line 5. So you wanna in external 5, do you wanna take it from here or take it from here? Only one. You cannot do both. Only one of them at a time. You cannot do both simultaneously. Is that, guys? Okay. This is something you can control. This is something you can program. How I can program? That's what I'm going to explain right now. So actually, who takes care of this one? We have what we call system configuration controller. Okay. So we have system. We have a hardware unit. This hardware unit is called system configuration controller. Actually, this one is going to take care of this one. It's going to connect line 0 either to this one or this one for sure. Again, don't be confused. We don't have all of that. But here I'm explaining in general if we have more, okay, for other processors, so if we have more, okay. So actually, so this one can do it, okay. So how I can do it? I'm going to explain to you how can you select? Do you want to select BA or BB? How can you do it? Very simple. All what you have to do this way. Look here, guys. We have this register, okay? This register has 4 bits for 0 to select. For everyone to select, you can select A or B, okay? So here, so this the first 4 bits for line 0, line 1, line 2, line 3, line 4 here for this one. So it's like you have an array, as you see here, guys. You have an array, as you see here. So the first one here, this one for actually line 0 to line 3. This one here should be from line 4 to line 7, and so on, this way. Okay. All what you have to do, oh guys, number one, if you are programming line 5, so I have to program this one. I have to, okay. If I ask you in the quiz, you have to program line 11, okay, so you have to do, you have to program this one. If I tell you have to program 13, so it has to be here in this register. Is that okay? Very easy. So all what you have, for example, here in this example, I want to program this one here. Okay, so you have 4 bits. And these 4 bits, if you put 0, 0, 0, so actually it's going to be connected to port A. If you put number 1, it's going to be connected to port B. Or if you put number 2, it's going to be connected to C and so on. Again, in our case, we have only one A or B. Is that okay, guys? So very simple. So if you want to connect the line 5 to port, if I want to use BA5, so I have to put 0, 0 here. That's it. Very simple. Also, if I want to use BB5, so all what I have to do, I have to put 1, 0, 0 here. Okay, guys? So number 1, you have to know which, because every register, we have 4 of them, 4, as you see here. Everyone can do 4. You have to know which one you have to use here. And then inside this one, you have to see, should I put here or here or here? Is that okay? So for that, all what you have to do, guys, as you see here, what I did, because I want to use external 5, so I have to use here number 1 here. This is number 1. Okay. So, and what I'm going to do, I'm going to clear these 4 bits first, and then I'm going to decide if I'm going to use B, so I have to set this one. So I'm going to do it in 2 steps. Okay. So the first step, as you see here, I'm going to clear the 4 bits. But which 4 bits you want to clear? The second 4 bits, as you see here, because I'm doing this one. If I ask you in the quiz, you have to do this one. Again, it's exactly the same thing, but I'm going to put F here and 0 here. That's it. You understand what I'm saying? If I ask you to do this one, so it's going to be 0, F, 0, 0. Anyway, so number 1, I'm going to use this instruction to clear the 4 bits. Okay. Number 2, after that, if you want to use port A, you don't need to do anything. If you want to use port B, so you have to set this bit. You have to set this bit using OR operation here. Okay, guys? There is another way. Instead of remembering numbers this way, we have all these numbers here, okay, guys, are already defined in sometimes people like to use English names. So this already defined in the project you have. So either if you like I don't like these ones actually, but anyway, if you like them, it's exactly the same thing. So this one is exactly equivalent to this one. I think I have a picture here. So if you go to this file here in your project, you will find all the ones I have here, they already defined here. So they already look here. Okay, so they already defined all these constants are defined here. So anyway, if you want to use, I think it would be easier just to use numbers. Let me tell you the conclusion. The conclusion is that I want to program this one for port A. Okay, all what you have to do here, I'm gonna put here 0, 0, 0, 0. That's it. I'm done. I am done. How can you do that? Yeah, using this instruction. I'm gonna clear these 4 bits. That's it. Okay. If I want to do the same one for port B, I would put 1 here as well. After I clear these 4 bits, I'm gonna put 1 here. Okay. Any questions? Okay. The last thing you have to do, guys, I told you we have this controller. This controller is controlling which port has to be connected to which line. This controller, is that okay? So that's why, as you see here, this register is under this controller. Okay, similar to what we did before, if you remember. Also, before you do that, you have to enable this controller. So this controller also has enable or disable. So you have to make sure this controller is enabled. So that's why you have to write. So how I can do that? We have a register here, guys. Again, I know that maybe you are too many registers. That's okay. Too many registers. That's okay. But I'm gonna put everything in one program. All the time you can use the same software. That's it. Yes, you got what I'm saying? So anyway, so now also you need to enable this controller. Before you use the controller, you have to enable it. How can I enable it? Very simple. We have this register. we have only one bit here, the first bit in this register to enable it. So you have to use this one. Okay, guys. So number one, I have to make sure you enable the controller. Number two, after you enable this controller, this control that takes care of this multiplexing. Number two, you have to connect this one here or here. Okay. Anyway, what else do you have? Okay, I'm done. So let me summarize what I said. What I said, guys, every time you wanna use the external pin, all what you have to do here, number one, this is how can you enable. Okay, this is a peripheral enable bit, or you can use NVIC enable bit here as well. You have to do it for configuration. You have to do configuration for the pin. You have to do the configuration for interrupt. You want to trigger interrupt at rising, falling, or both. Also, you have for this controller, this controller you have to select. Are you for which line you are using, and for the line you are using, you want to connect A or B. Okay, by writing here. Okay. Also, don't forget you have to also to enable this controller, because we're going to use this controller. We have to enable. Okay. What is left? What is? I'm done with the main program now. For the interrupt subroutine, this is the name you have to use, as I told you. If you have interrupt for 0 or 1, you have to use this one, and inside it you can check if this one, if this function is executed because interrupt is 0 or line 0 or line 1. You can check inside here. Same thing here, you can check inside here. This one is used for line 2 and 3. This one is used for from 14 to 15. So any interrupt comes from line 4 to 15 has to be here. Okay. For example, if it comes from 4, I want to do something. If it comes from number 7, I'm going to do something else. Yes, you can do that, but it's going to be in the same subroutine. It's going to be here. Inside the subroutine, I'm going to check. Are you calling this function because of 4 or because of 7? If it is 4, you need to have if statement. Okay? So, and also I'm going to tell you how can you know if it is triggered because of 4 or 15? How can you know? From the binding bit. See which binding bit is 1. You got what I'm saying? So where is the binding bit? You remember when I told you about the binding bit when you raise your hand, and I told you don't forget you have to clear it. You got what I'm saying? So where are these bits? Very simple. All the, again, you remember we can have up to 16 interrupts from 0 to 15. All of them are in one register. That's it, in this register. So we have this register, external BR. BR stands for binding what? Binding bit register, something like that. Okay, or binding register. Okay. So for this register, guys, we have one bit for each line. Line 0, line 1, line 2, line 3, and so on. Okay. So if there is any interrupt from line 1, so actually this one should be 1. Okay. And you have to clear it, but you have to clear it. The way actually the way we clear it by writing 1, not 0. That's how it works. Okay. So you have to write 1 to clear this bit. Don't forget this one. Okay. So if I think the mistake. I'm sorry. This is not line 0. This is line 5. I'm sorry. Okay. I'm gonna clear it. I'm gonna clarify. I'm gonna correct it. Okay. So in the quiz, if I tell you we wanna use line 7, very easy. All what you have to do instead of this one, just put 7. That's it. Can it be easier than that? Okay. Because instead of putting again. If you want to clear the binding bit, you have to write 1, not 0. You have to write 1 in this location. Okay. You told us you can check where is the source of the interrupt. That's okay. All what you have to do, look, guys. If I want to check, for example, if the interrupt is coming because of 4, okay. All what you have to check if there is 1 here or not. That's it. So, for example, you can do something like that, because this function is going to be called. If you have interrupts from 4 to 15, right? So I want to know which interrupt triggered this one or called this one. You can, for example, you can do something like that. So you can check. I can put, as usually we do it, as you see here. I'm gonna calculate. I'm gonna put 1 here, and then I'm gonna put 0 everywhere. I'm gonna do end as we did before, as you see here. I'm gonna say if the result does not equal 0, that means it's coming from number 5. okay? It's coming from line 5. Again, if you want to check if it's coming from line 7, just to put here 7. If I want to check if it's coming from number 15, just check bit number 15. That's easy. Just again, we have a register. This register, every source, every line has a hand. The hand here is a bit. You need to know which one raised its hand. That's it. You got what I'm saying? You need to know which bit is what. Any questions? Okay. Nothing is new. I'm gonna just put everything together. What I want to do here, guys, is that I want to write a program. Okay. Every time I press a button here in PE5, the first one, every time I press it, I'm gonna trigger interrupt. And in the interrupt subroutine, what I want to do, I want to flip the LED. If it is on, I'm gonna make it off. If it is off, I'm gonna make it on. Is that okay? So every time I trigger interrupt, you are gonna execute a subroutine. In the interrupt subroutine, I'm gonna say flip the LED. Okay. So as you see here, guys, what I did is, okay. What I did here, number one, because I'm using LED 0, I'm gonna do the initialization for it. Because I'm using BE5, I created a function, as you see here, for the initialization of BE5. I put here everything I explained. So as you see here, guys, in the first part here, just give me 1 minute. So in the first part here, here I configure the pin as input, as I explained to before, okay? In the second part here, I'm gonna use the system controller, as I told you. I have to enable it, as I told you. Also, I have to see external. I have to tell you want to connect port A or port B. You remember? Okay. Also, here you need to select is that you wanna rising, you wanna trigger interrupt at rising or falling or both. At the very end, you have to enable. Okay. So in the quiz, I'm gonna ask you to write a function like this one. The only difference will be, for example, here, this one for BE5. So, for example, if I tell you BE2, for example, so just to put here 2, okay? Here also 2, okay? Here, no, sorry, here is not 2. Here you need to know what is the interrupt number for line 2 number. But here you have to put 2 and so on. So that's what I want you to do. I made for interrupt 5. I can ask you to do it for anyone else, okay? The last thing here, guys, is just, I'm done. The last thing here, this is the interrupt subroutine. So every time I press the button, this subroutine is going to be called. Look what I did here in the subroutine. Number one, I'm going to flip the bit, as you see here. Number two, don't forget, you have to clear the flag bit, as you see here. And just here, I add the code for debouncing. You understand what I'm saying? So every time I press the button, this subroutine is going to be called. And then you write whatever you want to write here. Okay. This is a very simple program. Look here, the main program is empty. Because this is just a simple program. I'm doing only one task. You understand what I'm saying? You can add another task here if you want. So anyway, I'm going to elaborate later. So again, all what we have, guys, here, again, you have the program, you have everything here. So every time I press a button, okay, we are going to execute this subroutine. Write whatever you want to write. So in this case, I just want to flip the LED. Okay, I can do something else quickly in 1 second. Look here, guys. I can connect this pin to a sensor. The sensor is gonna, for example, there is some kind of infrared sensor. Infrared. Every time I can put it at the entrance of a store, Walmart or any store. Every time when someone enters a store, you are going to hit the light. As an infrared, you cannot see it. Okay. Once you cut the infrared, you are going to trigger a pulse to go to here. Okay. And then after that, I can make like a counter. I can count how many events happened, how many persons entered the store, how many cars crossed the street, for example, or passed by the street. Because every time there is an event, you just are going to make a pulse like this one. Okay. Later also I'm going to explain we can use the same idea to measure the motor speed. If you have a motor speed, okay, we use the same idea. So if you have here a motor, we can connect here like a disc. The disc has two holes this way, and this disc is going to go through infrared here, so that every time when it is, for example, you are going to generate something like that for a complete rotation. So every time there is a hole, you are going to, the light, it's going to be something like that. So the light is going to come from here to here. So if you have a disk here, no light, so I'm going to get 0. When the hole comes here, so I'm going to get a line. So if the disk has 2 holes, so for one revolution or one rotation, I'm going to get 2 pulses. So if you want to measure the motor speed, simply I can see how many. Anyway, so the same program can be used for different purposes. That's what I want to tell you. All what you have to do is just to change whatever here. You understand what I'm saying? So you already have a subroutine. Every time there is a pulse, the subroutine is going to be executed. Okay, just so you can use it. If you can put a counter here, you can count. If I put, like, you can do whatever you want to do. Every time there is a pulse, you can just change here as a subroutine. Anyway, okay, guys, thanks very much.